Okay, ladies and gentlemen, looking at some new material here, some probability rules. You guys started off with some vocabulary to just become familiar and aware of what we'll be working with. You then worked on a tree diagram worksheet, which you've probably seen tree diagrams before. So that hopefully is pretty straightforward. When you think of probability, if you think the probability of rolling a 2 on a dice, a six-sided dice, you have one opportunity out of six total, right? It's the what you want over how many outcomes there are is your probability. And there are certain rules, okay? There are certain guidelines here. And I kind of sum it up in these notes that I did scan these and upload them to Google Classroom as well for you to read through and flip through. Just the first rules. Probability rules. Rule 1, for any event A, we name events A, B, C as event A could be flipping a dice. Event B could be drawing a card. So don't get mixed up on that. It's just naming the event so that it is specific. Will always be between 0 and 1, and that's the probability of getting anything can never be less than 0, and you can never have more than 100%, 100% greater chance of having the probability of an event. The sum of all the probability outcomes always have to be 1. So no matter how many outcomes, if you think of flipping a coin, 1/2 for tails, 1/2 for heads, 1/2 plus 1/2 is 1. That's how that one works for rule 2. Rule 3, A's complement. Okay, that's a little A apostrophe mark right there. Okay, that's what we call a complement, or we also call it A prime. In a sense, is the opposite. Okay, so for example, it's 1 minus the probability of event A. So if I have the probability of event A is rolling in a 1 on a dice, which is 1/6, the complement would be everything else, which is 5/6. 1 minus 1/6, which is 5/6. So that's what a complement is, or prime. It's what's left over, in a sense. The next thing is your mutually exclusive and non-mutually exclusive events. And when we think about mutually exclusive, that's all you need to know, because then you can tell what non-mutually exclusive is. But mutually exclusive events cannot happen at the same time. For example, flipping a coin and getting heads and tails at the same time is not possible. You cannot drive north and south at the same time. Okay? So those are mutually exclusive events. Non-mutually exclusive events would be, let's say, drawing a king and a heart out of a deck of cards. Well, a king of hearts is a option, so that would be non-mutually exclusive. So that kind of jumps you right into your first addition rules, multiplication rules worksheet. 1 through 6 are they mutually exclusive or are they non-mutually exclusive? Okay, and if we look at 1, get an even number and get a number less than 3. Well, that'd be 2, right? The answer 2 was even and a number less than 3, so that can happen. So therefore, that is non-mutually exclusive, for an example, in those scenarios there. As you work through the rest of those problems, you'll end up seeing some scenarios where we often call them union, also known as or events, or intersection, also known as and events. Okay, and they are designated by in a sense, think of it as a U and an N. U stands for union, or events. The probability of flipping a heads or a tails would be 100%, right? That's optional. Probability of flipping a heads and a tails is 0%. That can't happen. So there's much different terms when it comes to and or, and those eventually are summed up right here. These are mutually exclusive events, okay, also known as disjoint. A or union B, you just add up the individual probabilities, the probability of event A and the probability of event B. And A and B, well, they can't happen. If they're mutually exclusive, that means they cannot happen at the same time. Therefore, this cannot happen at the same time. You can't get two things at once, so it's always going to be 0. for Rule 4. Rule 5 is your non-mutually exclusive events. These are your more common ones. This one right here, if you're going to put a note down, put an asterisk down, these are your more common rules to follow. Okay, if we think of just straight multiplication, the rolling of 1 on a dice and heads on a coin, well, it's 1/2 and 1/6, it's 1/12. Multiply those two together, it's 1/12 of actually rolling a 1 on a dice and a heads on a coin. So those are your more common questions here. Probability of A or B, A union. You do have to take a probability of A plus the probability of B minus the overlap, because they do overlap. They're non-mutually exclusive, so they can happen at the same time, and that's where this overlap comes from, to help you solve those problems right there. So as we're looking through this worksheet, and mind you, there's many example problems in those notes. Okay, many example problems of remembering, so on and so forth. As we look through some of these problems, I trust 7 through 10 will be very straightforward for you. Number 11. The best way to do these sorts of questions, okay, it says a recent study of 200 nurses found that 125 female nurses, 56 had bachelors, so on and so forth, is to draw out a little Punnett square, in a sense, a little graphic organizer to help you organize your numbers. If you notice through this, I have 56 females that have bachelor's degree and 69 that don't. Well, it says the 125 female nurses, 56 had bachelor. You can do the subtraction to figure out the non-degrees. And then I also did that for males. So now, a female nurse with a bachelor's degree, well, I have female nurses with a bachelor's degree. That's 56 out of female nurses. That's 56 out of 125. That's what allows you, this graphic organizer allows you to straight focus in on what you are looking for. Okay, it's focused on female nurses, therefore you can focus in on that row. B, a male nurse. Doesn't matter what it is, whether they have a degree or not, male nurses, that's 75 out of 200. Okay, you're comparing male to female now. Male nurse with a bachelor's degree. Well, that male nurse right there has a bachelor's degree out of a total of 75, so on and so forth. So you can answer those questions as you go. 12, 13, those are all similar sorts of questions. You notice 15, they already provide you a chart. Those are actually really nice. 15, they provide you a chart. Okay. 16, independent events and dependent events. The biggest thing to think of is, does the second one depend on the first one? For example A, tossing a coin and drawing a card from a deck. Those have no relationship to each other. Okay, they're completely independent. Therefore, that is an independent event. But if you look at B, drawing a ball from a bag, not replacing it, and drawing a second ball, if you think of the marble problems, you're not replacing it. So the second event depends on the first event. The second happening, drawing a second ball, depends on what happened on that first one. Therefore, that's a dependent event. So, dependent, independent, those, so on and so forth. Go ahead, work through these questions. I understand it's brand new material. Okay, questions are going to be completely okay. After tomorrow's Zoom meeting, remember we will have a Zoom meeting at 4:30 tomorrow, I will upload the answers. So that way you have those to refer to, okay? But go ahead and ask questions if you need to, and I hope to see you tomorrow. Bye.